This video is about skeletal structures. Now that you have drawn multiple constitutional isomers of structures with multiple atoms in them, you will have realized that it's getting pretty tedious to draw every single atom and every single bond. Luckily for us, there are several ways we can try to save time and effort. In fact, we can be very lazy. The first way is the condensed structure, where we don't draw the bonds unless they are double bonds or triple bonds. This makes life very easy when you're trying to type a structure, i.e., if you're sending an email to a person you are collaborating with and you need to give them a structure, but you don't have the software to draw the picture. However, there are severe limitations to using condensed structures when you have a much more complex molecule. The most standard way of drawing structures is with skeletal structures, as it is much easier, but you do have to follow several rules. Rule 1, any carbon-carbon bond becomes a line. Rule 2, we assume that at the end of a line there is a carbon unless another atom is shown. Note that if we have multiple carbons in a row, we draw it as a zigzag so that we have corners, each corner indicating a carbon. Rule 3 is that no hydrogens are ever shown unless we want to emphasize it. And rule 4, any and all other atoms must be shown. This includes hydrogens bonded to other atoms. So time to practice. Draw the skeletal structures of this condensed structure and this full structure.
You may pause now, and here are the answers. It may help you to number the carbons so that you can double check your structure. Let's do another practice problem. Draw all constitutional isomers of this chemical formula using skeletal structures. You may pause now, and here are the answers. How many did you get? Here's a bonus question about degrees of unsaturation. So if you're given the structure, how might you calculate the degree of unsaturation for said structure? Well, there are two approaches. You may count them off the structure itself, i.e. a degree of unsaturation per double bond and per ring, or you could just calculate the chemical formula of the structure and then calculate the du from that. Have a go. You may pause now, and here's the answer.